What will be the angles for an isosceles trapezium? How the angles are related? Let's discuss about it through a problem. Hello students, I'm Deepon. I'm a faculty here in Cheenta. Today, we will solve a problem from Australian math competition in the junior section. In this problem, we discuss about the angle chasing, the properties of equilateral triangle, squares, and most importantly, the isosceles trapezium. So let's see what is being asked. Let's get into the problem. So this is what given to the problem. The three squares, square 1, square 2, and square 3 are of same measurement. That means they're congruent actually. And as they're congruent, we can directly conclude that the triangle DNC has to be an equilateral triangle. That's very important and interesting. Why? Look, if we go into the angles, then we can understand this angle will be 60. And actually all the angles are 60. On the other hand, we know the angles in a rectangle are 90 degrees. So these are 90 degrees and all the angles of squares are 90 degrees. We can observe an interesting quadrilateral here. And the quadrilateral is ADNM. So what type of quadrilateral it is? If you observe very carefully, you can understand that these two angles is total angle DNM would be 60 plus 90, which is 150 degrees. On the other hand, similar for angle NDA, this angle is also equal to 150 degrees. Now we concluded that these two angles are 150 degree each. On the other hand, if we try to draw the angle bisector of C in the triangle, it would look like this. Now if you look properly, this is actually the line of symmetry for the quadrilateral. That actually implies this is an isosceles trapezium. Okay, now it is easy to conclude that these lines actually firstly parallel to each other. That's the first thing. That means sum of angle DNM plus angle NMA has to be 180 degree. The sum of co-interior angles within two parallel lines. So that is 180 degree, and we know this is 150 degree. We found that. That implies angle NMA is actually 30 degrees. Okay, so we got this angle. Our target is to find angle AMT. So if we can get the remaining part of AMT, which is this, we are done. Okay, now let's focus on this particular portion. So if we look into the triangle, particularly triangle NMT, look, we were given three squares of same size. That means this side is equal to this one. That indicates this is an isosceles triangle. That means the angle to the equal sides are equal as well. So let's figure out what about this angle. We know this is 90, this is again 90. So this will be 360 minus 90 plus 60 plus 90. So 360 degrees minus 90 plus 90 is 180 plus 60 240. That is 120 degrees. That means this is 120 degree. And we know some of the angles of a triangle is 180 degrees. That means these two are equal. So let's consider them to be x and x. So this leads me to 120 plus 2x is equals 180 degrees. That means 2x is actually 60 degrees. That leads to find x is actually 30 degrees. So x is 30, and this portion we concluded that was 30 as well. So angle AMT was angle AMN plus angle NMT. That is 30 plus 30, 60 degrees. And that's it. So in this problem, we discussed about the properties of and angles of equilateral triangle and square. Secondly, we proved how we can go ahead with the properties of isosceles trapezium. And lastly, the angle chasing. Also in the middle, we included the isosceles triangles as well. So actually we did all the stuffs regarding the angles and trapezium squares and quadrilaterals. Hope you guys enjoyed the video, and there are many more things can be concluded from this particular figure. It's a very interesting figure to think about it. So let me know in the comments if you can find some few more insights from this particular video. Hope to see you soon again in the next video, and continue to do good mathematics.